So welcome to today's developer lesson. Today we're going to be discussing how to write testable code. We're primarily going to be discussing integrating our testing into our development flow. So when you actually think about writing testable code, you're thinking probably more along the lines of like unit tests, integrated tests. This kind of discussion that I'm going to do over actually a couple different presentations is actually going to be looking at the testing side of the development lifecycle from a developer's perspective. Um, but first, we kind of have to get out of our comfort zone as developers and actually put on our testing hats and look at an application or look at our code from a tester's point of view so that we can understand what might be missing or what we could possibly add to our coding environments or our development flow that will help the testers on the end of the life cycle so that they can actually write better tests or integrate with the software easier than per se if you were to leave things out. So today we're primarily going to be focusing on integrating tests into your development workflow. We're going to start by understanding your test environment. So what is the test environment? What kind of tools, frameworks are used? We're then going to be looking at how to integrate testing into our development flow. First, though, let me start out with a quote from Aristotle. Quality is not an act, it's a habit. So with quality assurance, with testing, these are things that you have to actually embrace. You have to actually turn it into a habit. It's not just something you can kind of just do on a daily basis. You kind of have to embrace this. You have to kind of really embed it into your daily habits, your daily tasks. So let's start out by understanding your test environments. So there's different things in a test environment. We have different types of test frameworks. There's different types of tools. And then there's different types of testing options we can use. Within the frameworks, we have these 6 particular frameworks. We have the module-based framework, which is a testing framework based on one of the popularly known object-oriented concepts, abstraction. The framework divides the entire application under test into a number of logical and isolated modules. And for each module, we create a separate and independent test script. Thus, when these test scripts taken together, build a larger test script representing more than one module. So essentially, you're breaking it down into smaller individual pieces that can then be run as a whole to test the whole application. The library architecture, testing framework is fundamentally and foundationally built on the module-based testing framework with some additional advantages. Instead of dividing the application under test into test scripts, we segregate the application into functions, or rather common functions can be used by other parts of the application as well. Thus, we create a common library constituting of common functions for the applications under test. Therefore, these libraries can be called from the test scripts whenever required. Data-driven testing, just like the name sounds, helps the user segregates the test script's logic and test data from each other. So it lets the user test data into or store test data into an external database, or you can store these into external files like XML, Excel, test files, CSV files, etc. The data is conventionally stored in a key value pairs. Thus, the key can be used to access and populate the data within the test scripts. Keyword driven. This testing framework is an extension of data-driven testing framework in a sense that it not only segregates the test data from the scripts, but it also keeps certain sets of code belonging to the test scripts into an external data file. These keywords and the test data are stored in a tabular-like structure, and thus is also popularly regarded to as the test-driven framework. The hybrid testing framework is kind of a combination of all these frameworks. The best thing about such a setup is that it leverages the benefits of all kinds of associated frameworks. And behavior-driven development allows automation of functionality validations in easily readable and understandable formats to business analysts, developers, testers, and so forth. Such frameworks do not necessarily require the user to be acquainted with a programming language. There are different tools available like Cucumber, JBehave, other things we can look at would be like Sauce Labs and some other different types of tools. What type of testing tools are out there? This is kind of a common set from what I've seen in the industry. JBehave is more behavioral-based testing. Quick Test from HP is kind of your record, playback type testing. Selenium, where you're actually scripting tests. You can do record playbacks. You can actually write individual scripts for all your tests. Or you could kind of devise your own framework and do like page-driven development using these Selenium web drivers. Sauce Labs, they are kind of the Swiss Army knife of tools. They have just about everything, just depending upon what you can pay for. So if you have a very small budget, you could do some very simple testing with them. Or basically, if you have a large enterprise budget, you can kind of build out your entire testing library framework with them. Jenkins, Cucumber, just some other ones that are out there that you can look at. Some testing options. So from a testing perspective, we have what are called functional and non-functional tests. So under the functional testing, we have things like unit tests, which is a testing technique using individual modules are tested to determine if there are any issues by the developer himself. So we're actually testing individual units, use cases. These help reduce the defects, reduce the cost, and improve this designing of your code. We can then do integration testing. The purpose of integration testing is to verify the functional performance and reliability between the modules that are integrated. You can think of this as the Big Bang integration, top-down or bottom-up approach. We can do system testing, more of a black box testing technique performed to evaluate the complete system, the system's compliance against specific requirements. In system testing, the functionalities of the system are tested from an end-to-end perspective. Typically, system testing also falls within a lot of the non-functional testing, so like the performance testing, the load testing, stress testing, and everything else you see kind of down at the bottom section there. Smoke testing is a testing technique that is inspired from hardware testing, which checks for the smoke from the hardware components once the hardware power is switched on. Similarly, in software testing context, smoke testing refers to testing the basic functionality of the build. Things like identifying the business critical functionalities, designing and executing the basic functionalities, ensuring that the smoke tests pass every build in order to proceed with testing. And these are basically just a quick and dirty test to make sure that the base functionality is working. Interface testing is performed to evaluate whether systems or components pass data and control correctly to one another. It is to verify if all the interactions between these modules are working properly and errors are handled properly. Regression testing is more of a black box testing technique that consists of executing those tests that are impacted by the code changes. So, and typically a lot of shops do this at the end. So once everything's ready to go, you have your manual users go out and test the system, and then you have what is called a regression test, which runs through all the current existing tests to test all the code changes to make sure nothing broke. And finally, we have acceptance testing, which is a testing technique performed to determine whether or not the software system has met the requirement specifications. These are various forms of acceptance testing. Could be user acceptance testing, business acceptance testing, your alpha and beta tests. So how do we integrate testing into our development flow? Well, some of our options here, we have write testable code responsibly and in moderation. So this can depend on how you balance your long-term risks with short-term reward. In many cases, it depends on your time scale, the size of code base, the worst-case scenarios of failure, and many other factors. These can also lead to many individual tests, testing individuals' use cases or data sets. While these testing practices can save you a lot of time and effort down the line, sometimes it makes does make sense to create more single or larger base tests that will test the entire base of your system. It just kind of depends on the time and risk you want to put into this. Test behavior, not implementation. This is kind of key. So a lot of mistakes are made because you're actually testing more of the implementation, not the behavior. Yet when you write a new class or implement new functionality, think of it more as a set of inputs that produces an expected set of outputs. So try to avoid making dubious testable classes that inherit from any given class that you are testing to make sure such and such members were set to this, or a particular object has been cached. Think more like decoupling your classes, or instead take the approach of testing that the actual use cases are given the right output from the input, such as if such and such member is set wrongly, this should result in the output not being what is expected. Then if the internals of the program get tweaked or changed, your tests don't need to change. The design changes will mean having to fix the test, but this has the side effect of making the tests that are kind of more free from documentation. They give a more demonstrative approach as to how the class should be used and the expected result of each case. Next, we have idiot checks, your first pass. A lot of people think that unit testing or creating tests, or once something is set up and it's automated, you kind of don't have to, you think in terms of like set it and forget it, or in terms of like, we have these new self-driving cars that are out there on the roads. Well, they can be prone to error. They're less likely to error than humans driving. Same kind of goes with idiot checking your first pass. So while you may have a large set of automation tests, building the test the first time, you really want to make sure that they pass the first time before you just drop them out there and run them. So before you ever try to manually run through a set of features, start by writing tests and get them all to pass. It saves a lot of awkward stepping through and examining your variables to figure out exactly like where your null pointer might have been, or like a stale state exception if you are trying to validate a element on a web page. Even because different browsers function differently, so you may want to do different browser-based testing. Prevent breaks in other parts of your code base. So commonly in software development, typically when you go fix a bug in one piece of code, chances are you might break something somewhere else, or you could potentially create a memory leak. By automatically running all the tests in your code base on a seemingly solid commit, you could catch bugs that would otherwise be incredibly tricky to track down. So when you don't have any types of testing in place, or you have no automation in place or regression testing in place, you really are taking a crapshoot when you go make a change to code and expect the users to catch everything. By creating test systems, by automating tests, it helps you catch things like this. Or if you make changes to seemingly innocent pieces of code, you might be breaking something else somewhere that you may not be looking at or testing. Other things, orthogonal code design. There are a lot of reasons to make your code nice and modular set of building blocks that can be rearranged or reused. Writing your classes like isolated mini APIs that depend on other classes as little as possible makes testing a whole lot easier than having to kind of delve through a tangled web of functionality strewn across your code base. This way your test can cover that one block of functionality and isolate bugs to individual classes. This gets back to the whole clean code, make sure that your classes and your functions really have a defined purpose. They have specific use cases they're applying to. And you also want to avoid coupling your code so that you don't have too many dependencies across different classes and methods. mock your dependencies. Anytime you create an instance of one of your class dependencies in a test, you're now testing more than just your class. That's okay in terms of data structures. However, of course, but if that dependency contains logic, your test no longer isolates. It's no longer isolated to the issues of just your class. It does usually require the dependency to have to be handled via some interface. So if your class that you're testing has other dependencies on third-party libraries and things like that, you're going to potentially then have to go out and actually create tests that test those dependencies within your individual tests. So you're not actually testing a specific unit, but you're now actually testing multiple dependencies. So you may have to actually kind of create a test that builds the environment with those dependencies so that you can test everything. Injector dependencies. Set up functions that takes the class dependencies, process checks, and if necessary, cache them. This allows you to dunk whatever mocks you have in there and provide that bit of self-documentation of what the dependency requires. And finally, defining code standards with testing in mind. This is kind of the key piece of this particular discussion. So when we want to write testable code, we have to make sure that the code has the code base itself, not necessarily the code, but what the code produces, be it with GUIs, if you're creating a web-based application. If you have to test your code outside of the applications, meaning you're actually going to have to do something beyond unit tests, where unit tests are essentially testing an individual function method where, like say you have an addition method and you're testing, okay, if I pass in two variables, it should add them together and I should get the sum of the two. Coding standards can mean many different things. Ideally, though, defining a coding standard that ensures that all web elements have unique IDs. All database values columns have very specific field names. Naming things is critical for testing. So on the code side of things, yes, you can create classes, you can create code snippets and method names, class names, things of that nature that are very clear, very definitive. Except when you go to build a web page, if you just throw your data out onto the web page and create inputs for form inputs, and you just use, like, say, name, first name, last name for the element IDs, that's great. But if you have multiple fields on multiple pages that are very similar, for instance, say you're doing say you're Amazon and you get to the shopping cart page and you want to bill your purchase to one person, but ship your information to another person, you potentially have two different customer information forms on the same page. So you could have one that could be billing first name, last name, and then you could have another one being shipping first name, last name. If you just named them both name, trying to test that, you're not going to know which variable or which input to test. So when you define the coding standards, you also want to make sure that you're defining your naming conventions that make sense not only to the developer, but also to the tester. So when you're coming in and you're actually testing things like a web page or a shopping cart, or whatever the application is, you're actually going to be able to go out there and actually say, okay, this input value, I want to test this, so I want to inject some data into this field, and it will go to, say, billing name, first name will be, say, Mike, billing last name will be Smith, and then the shipping first name could be Sarah, and then the billing last name could be, or the shipping last name could be Jane. That's just input fields. Things that people don't think about, though, with web pages or other visible elements for testing are things like the text that's actually being displayed on the web page itself. So a lot of things, especially in the new HTML5, CSS3 generations, a lot of things are wrapped in divs, a lot of things are handled with CSS, and a lot of tag elements typically use just names or class names. If you don't wrap things with IDs as well within your tag elements, you could potentially end up with duplicate duplicate descriptions of tags. Really, you want to kind of use IDs for everything, but not go too far overboard. So you don't necessarily have IDs around multiple divs, but if you have any text or anything that gets visibly displayed on the screen or even hidden that can be shown later, really should have IDs. That way you can always go in, scrape it, pull it, and compare it with automation testing or even with record and playback testing. So those are just some of the key things with defining coding standards that you want to keep in mind from a testing perspective. However, there are some cons to kind of building your testing into your development. So some of the benefits aside, testing can be a pain to write if the production code is awkward to reproduce in a test environment. So if you have a very complex application or you just have a straight up desktop application, writing external tests to test your application may be difficult. Now, if it's a web page, you can use things like Selenium and JBehave and some of those other tools we talked about earlier, or some other frameworks to test it externally. If it's internally, you're going to be doing more unit testing. Other problem with this is you're going to have to constantly maintain your tests. If you deploy the wrong framework, or if the framework you currently have implemented within your company for testing is too broad, the constraints is going to be very difficult to maintain. So you're going to be constantly maintaining and updating your testing. If you have a good framework in place, then the negativity or the impact of constant maintenance could go down. Tests may be difficult to write. If you have an old legacy or an old behemoth application that you're trying to write tests for, it may be hard. There may be a lot of coupling going on. There may be a lot of mixed use cases within particular classes that you're going to have to kind of differentiate and pull out. If you're just getting started, there will be a lot of refactoring going on. You're going to be going back and forth. You're going to find that some of the classes may be coupled, and you'll have to decouple them or break them out so that you can actually test individual test functionality. Legacy testing can be extremely hard, but if you take this concept of integrating your testing within your development, taking those legacy systems as you rewrite them, you could do one of two things. You could go through and fight with the legacy system, refactor the legacy system enough that you can actually get all your test cases built or your data sets built for testing on the legacy system. And then when you go to refactor, rebuild your legacy system into more modernized tools or languages, you already have those use cases. You already have that data set. So now when you build your new or basically rewrite the software into more modern technologies and software, you basically just reapply the testing tools and data sets to make sure that everything still works the way it should. However, if you make drastic changes to the interface, you are going to have to then go back and refactor all your tested data sets again to the new framework. So let's review. So we talked about some of the different environments, the testing tools and frameworks that you perceivably have from a tester's point of view. Kind of broke them down, the different types of frameworks, and the different types of testing options you could have, the functionality, the unit testing, the load testing. These are things from a developer's perspective you really don't think about, but if you're trying to write software that is testable, then you're going to have to think about these things. These are things that you just have to be aware of. So as you're writing code, you make sure your code, basically think of it more as kind of test-driven coding, where you're actually going to start breaking down your code into smaller pieces, more module that can be individually tested. And then integrating the testing into your development flow. We talked about some of the different types, injecting your dependencies, mocking your dependencies, and some of the different types of software standards or coding standards that you could apply to your development lifecycle. Any questions?
Was I off mute this whole time? Yes, I was going to ask about when you're going through your cons, it made me wonder something. And I don't know quite how to phrase it. The thought is sometimes we can over-engineer things, but in my mind, a balance and maybe even a fine line where it's engineered just precisely, and if you do anything else, it becomes over-engineered. Well, when it's engineered just precisely and things are a little more coupled, then I guess what's the balance between your engineering and testing, right? Because if you want to really design something well, maybe it behooves you to make testing a little bit more difficult. I don't know. Can you talk about that a little bit? If that makes sense.
I'm trying to make sure I understand the question. So in your mind, you're thinking from a design perspective, when you're designing this software, so you're thinking where testing should not be included or it should be included?
Obviously, we want to include the testing in the design period, but I wonder how much. I just wonder what's the balance when you're thinking of design and you're doing design. How much should testing or trump, I should say, good design software, or is it that well-designed software is easily testable? Is that the trade-off? I'm not sure.
Okay, I think I got it now. All right, so one of the things that when developing software, I see this mistake made a lot of times. So they will go out, you'll get all the business requirements. So if you actually have a good requirements staging area, if you go through the development lifecycle and you actually go through and you gather all the requirements at the beginning. Now, not necessarily all of them, but you gather most of the requirements and then you build out some specifications for what the software should be. That's essentially going to be your guideline or your kind of blueprint for your use cases. So that is essentially your test cases. That's also your use cases or your scenarios for what this software is going to be, what you're going to be building. So when you go build it, if you build it correctly and if you apply, object-oriented principles and you don't put everything into one or two classes, things should fall into inherently a good structure that can be tested. However, a lot of times that's not the case. A lot of times classes will be coupled. A lot of people try to do object-oriented design, but there are times where that isn't always implemented correctly. And in those cases, if you're not testing as you're going, if you're not running unit tests, or if you don't essentially have written your scenarios well, You could have situations where you have dependencies that should not be there. So you have one class that depends on another class where really that dependency should be pulled out and add another layer.
Hmm.
And if you write your tests as you go, you'll catch that. But if you're waiting to the end to write all your tests, now you're in a situation where you're going to have to go back and refactor.
I see. That's good.
And I see that more and more. I see people actually go out and implement, especially if you're just trying to do a proof of concept. You could seriously get into a situation where your proof of concept was just quickly hacked out, not well thought out, just trying to prove a point, but that now becomes production code.
Right. Yeah. That's going to take some thought then. That's good though.
It's just my 2 cents on this one. I think there is it's sort of like if you just think about general implementation, there are ways that you can go about it that are better. That are either best practices or a little more stable or more scalable, or less fragile. And I think that one of those things that the way you do your implementation is somehow is at least partially informed on what is the goal of whatever it is that you're implementing. It depends what you create to do throwaway code that's only run once. Probably going to be a little different than what you do with code that's going to be run a billion times a second. There's things and considerations that come into play with that. And I think with testing, it's sort of the same way. Feature or facet of it is that there are ways you can do stuff that will make stuff you can implement that will make things difficult to test or easier to test. And I think it gets into that's why test-driven development can be of a benefit. Is I think as you're thinking about not only the use cases but how you verify those use cases, I think it just brings more information into your thought process as far as implementing it, and it gets you thinking about ways and things and side effects that I think it helps you implement in a way that will make it sort of by default, like as Michael was saying, if you do it right, I think they do end up not becoming trade-off for the most part. I mean, there may be some cases where there is. There's and I've run into a few, I think, over the years where the way to implement it is easier, usually based on amount of code or something like that. But in doing so, because of the way it's implemented, it can put more work on the testing side. But more often than not, I think if you have all those things in your head while you're going through it, I think you're more likely to do a solution that works well. And you think about the most simple case of things like validations and notifications and feedback. It's real easy to create a lot of functions and methods that don't return a whole lot of information. You just go through and you fly through and you implement it and you're done. Well, when it comes to testing, if there's no feedback, then there's no points. You've removed points. Testing apparatus can go touch to see was this successful. But you know that it would be, in general, it's better to have that feedback unless you've got it. You're writing an application, you just want to like speed through it, and you don't want to spend the time giving feedback. You just want to like run through it, run through 1,000 steps and then just say I'm done, versus the cost of at every step saying, okay, I've completed another step. There is some trade-off there, but I think if you're thinking about the use cases, the stories, and which is really what drives the testing, which is their test points. Where are they, validating has this test been successful or has it failed? Then I think you're going to write better code.
Yeah, that kind of gets into the two of the behaviors I talked about, where you want to write testable code responsibly and in moderation. So you could go out there, like you said, and do a full data set test in one shot, or you test the individual use cases. But the other one I was, or kind of pushing a little bit, and this kind of gets to your point a little bit, Timothy, is one of the biggest problems even with a well thought out design, is it's typically tested on how it was implemented. It's not tested on how it should behave.
Mm-hmm.
So when you're actually implementing and you're designing and you're coding, you write tests to make sure that, okay, what I just wrote, I want to make sure that that works. Great, it works. Now, is that what the behavior of the application should be, or is that just how that piece of code works?
I see. Yeah.
So that's where you get back to, you essentially write the test to based on input, should I get the right output? So then you run that test against your implementation again, and if you get a different output from what's coming in, then you know your implementation's wrong because the behavior is not what it's supposed to be.
I see. So what I'm hearing from both of you is that, just keeping in mind the behavior, the use cases, what needs to be done in the long run is how you write testable code.
Right.
Gotcha.
Yeah, you want to test more of what it should be doing, or basically your tests themselves should be testing the use case. They should be testing what is the expectations? How is the software supposed to perform, not how it was implemented. If you write tests based on how it's supposed to perform, then all you're going to have to do is tweak the tests themselves to interact with the code versus having to constantly rewrite the code based on the implementation.
I see. That's good.
And that's why I kept this one kind of at this high level. I'm trying to make you look at your code more from a test, kind of with your test goggles on versus your developer's goggles. Because we're all developers. We all get in there. We all write code. And we typically can get into that put our blinders on where all we're looking at is the code. We're looking at, okay, what am I trying to accomplish? What is this thing I'm doing supposed to do? And we could be looking at just one small piece of our code base and fixing one particular piece of functionality, but whereas the application as a whole could have thousands of different functionalities. So if you fix that and you're only testing that, you're only testing that implementation, you're not testing the whole behavior. So what you fixed or what you did could have a larger impact to the behavior of the whole application.
Yeah. I'm just trying to think of an instance in which, that's happened, but I'm sure almost certain that that's happened to me where just implementing based off, even if it's just based off of, I can think of an instance where I'm updating a service class method, right? Or a service level method or a DAO level method. And because it's such a low layer method, it can be called and probably is called elsewhere in the application, whereas I'm just thinking about the issue in front of me as opposed to the entire behavior of the system. And because I fix one thing, I can easily break another. It's good,
Yeah, one way to think about it too, especially like if you're dealing with databases or even if you're dealing with APIs, you change a service call. So you say you're passing a Boolean back and forth, and you currently were passing it back as an int or as a bit of 1 and 0, and you've now changed it to a Boolean where you're returning true and false. That's a huge change. From your perspective, it could be minor, but whoever uses that data or wherever that data is displayed, that could now break, or vice versa. If you went from true and false to a bit of 1 and 0, it may not be displayed incorrectly.
Right.
I mean, that's just one particular case, but this is just something to think about from an overall perspective. As we continue to talk about testing and writing testable code in the future, I'll be getting into specific examples with unit tests and other particular areas like automation testing and that. This is just to get you thinking about testing as you're writing your code. Well, thank you for joining us today. We appreciate your time. And if you'd love to discuss any of our other topics or this topic further, shoot us a comment at info@developerner.com. Check us out on Developerner on Twitter. And we're also on Facebook at facebook.com/developerner, or just find us on our webpage, developerner.com/contact-us. This video will be probably on Vimeo or wherever else we post this, and you can see our other videos and blogs on our website. Thanks. Have a great day.